Section 10-5 and 7 covered pyramids yesterday. It's also covering cones, which is what we're doing today. So we're going to start off with a surface area problem. So we're going to find the surface area of a right cone that's going to have a radius of 9 centimeters and a slant height of 5 centimeters. So the first thing we're going to do is draw this cone. Cones have a circular base, so the easiest way is to start off with a circle as the base. Put a point up here and then connect the sides up there. This particular cone has a radius of 9 centimeters. That means that the radius is on part of that base. So we're gonna label it 9 centimeters. And it also has a slant height. So this is your slant right here of 5 centimeters. That's the only information you need for this formula, right? So we're going to write surface area equals 1/2 the perimeter times the slant height plus the area of the base. And we know the perimeter is really the circumference of a circle, so we're going to say 1/2 2 pi r times the slant height plus the area of the base, which is a circle, so pi r squared. Okay. What happens here is when you have 1/2 times 2, they cancel. And so it's just really pi r L plus pi r squared. So we're going to substitute in our values. Pi is actually a number. The radius is 9. The slant height is 5. So we plug those two numbers in there. And then we have pi times the radius squared, so 9 squared. And then we're just going to grab our calculator, and the first time we get an answer, it's going to be in terms of pi. So you're going to multiply everything but the pi. So hopefully you can do 9 times 5 in your head, but if not, you can do it on your calculator. You should get 45 pi. Same thing here. You're going to multiply everything but pi, which is 9 squared. Hopefully you can do that in your head. It's 81. If not, do it on your calculator. So you have 45 pi plus 81 pi. That is 126 pi. That's your pi answer. Sometimes they call it can't remember the word, never mind. And so let's attach the units. This one is in centimeters, so we say centimeters what? Squared. All right. To get your decimal answer, you're going to take 126, multiply it times the pi button, hit the equal sign. We're going to round to the nearest, tenths. So I got 395.8. There's a 4 next to it, so it stays. So 395.8, also centimeters squared. These are the two answers that you're going to need to give. Any questions on example number 1? Thank you. We're good? All right. Marion, it's for right now. Yeah. Half of 2 is 1. Yeah. Good question. All right. Example number 2. We're going to have another cone. This time we have a radius of 8 inches and a height of 15 inches. Problem is, we don't need the height. We need the what? We need the slant height. Okay? So this number right here, oh, you need this, Marion. You need the slant height right here, we'll call it x, okay? But you have the regular height and you have the radius. But you may notice that this right here forms a what? A triangle, not just any triangle, but a right triangle. So the first thing we're going to do is we're going to get the x by using the what? Pythagorean theorem, right? That is our hypotenuse, so we're going to say x squared is going to be equal to the legs squared and added together. So 8 squared plus 15 squared. So x squared is equal to 64 plus 225. So x squared is equal to 289. Just so happens that 289 is a perfect square. Anybody know the square root of it? No? Well, 15 squared is 225. Square root of 289 should be a little bit bigger than 15, right? It's 17. So this is 17 inches. All right, so now we're going to use our surface area formula. 1/2 the perimeter of the base times slant height plus the area of the base. So that's going to give us 1/2 2 pi r times the slant height plus pi r squared. These cancel, and so we're going to have pi times the radius, which is 8, times the slant height, which we just calculated is 17, plus pi times 8 squared. For your pi answer, you're going to multiply everything but the pi button. So 8 times 17 is, what is it, 136? And 8 squared is obviously 64, so 64 pi. Add those two pi's together, you should get 200 pi. This one is in inches, so inches squared. And then for your decimal answer, you're just going to take 200 times the pi button. I got 628.3, and there's a 1 next to it, so it stays. Also in inches squared. And there are your two answers. Okay. Anytime you have a circle and you're going to end up with pi, you're going to need those two answers. Any questions on example number 2? All right, I think you guys are ready to try some volume. I'll move this up in just a second. There it is. Straighten it up. All right, example number 3. Oh, shrink it a tad. There we go. So example number 3, this time we're switching to volume. So we're going to find the volume of a cone. It's going to have a radius of 7 centimeters and a height of 15 centimeters. So let's write our volume formula is going to be 1/3 the area of the base times the height. We know the area of a base on a cone is always going to be a circle. So the area formula for a circle is pi r squared. So it's going to be 1/3 pi r squared h. But let's draw our cone. There's our circular base. So let's draw in a radius of 7 centimeters and a height. Notice it says height, not slant height, of 15 centimeters. So from the center of that circle up to the opposite vertex is going to be, what is it, 15 centimeters. Right, so let's plug our numbers in. We've got 1/3 pi. The radius they gave us is 7, so 7 squared. Height is 15. All right. First answer, you're going to want to plug everything into the calculator except for this pi button. And you've got a 1/3. So we'll do the 1/3 last. I'm going to divide by 3 after I square the 7. So I'm going to 7 squared. If you know it's 49, go ahead and type in 49 times the 15. Then I'm going to divide that by 3 and hit equals. So I have 245 And I haven't typed the pi in yet, so that's 245 pi. This one was measured in centimeters, so it's going to be centimeters what? Cubed. Okay? Now for our decimal answer, we're just going to leave that 245 in there. Don't clear it. Just hit times the pi button, hit the equal sign, and it's 769.6, but there's a 9 next to it, so it's going to round up to a 7 and then become centimeters cubed. And there are your two answers. Any questions on example number 3? All right, one more. Example number 4. We're finding the volume again with a radius of 16 centimeters and a slant height of 34 centimeters. For volume, do we need regular height or slant height? Look at the formula. Do we need regular height or slant height? Regular height, and they gave us slant height. So we're going to use the Pythagorean theorem again on this one. All right, so draw your cone. Here's your circular base. We'll give it a radius of 16 centimeters. Draw the tip of the cone up here, and the slant height is 34 centimeters. But we're going to make a right triangle out of it. And this time, we're going to use the Pythagorean theorem again, but this time, the x is in for a leg, not for hypotenuse. So we're going to say x squared plus 16 squared equals 34 squared. So the x moved to a different spot because we're not getting the hypotenuse. Now we're getting a leg. All right. So x, simplify a little bit here. X squared plus 256. And 34 squared is 1156. So we subtract the 256 from both sides. And x squared is 900. So what's x? Anybody know the square root of 900? What's the square root of 9? 3. And then just add a 0. 30 times 30 is 900. So our height is 30 centimeters, okay? Now we can plug that into our volume formula. 1/3 area of the base times the height. So 1/3 pi r squared h. That means we plug in the radius of 16 square it. And the height we just found, which was 30. So let's type this in the calculator. 16 squared, I'm going to do that on the calculator, multiply it by 30, then divide it by 3 because I've got that 1/3 there. So my pi answer is 2,560 pi, and this one's in centimeters cubed. And then to get my decimal answer, I leave it in the calculator and I multiply it by the pi button. 8,042 point. I have a 4 there, but there's a 7 next to it, so I need to round up to 0.5.